Hi guys, welcome back to my YouTube channel. So in this last lecture, we have discussed some kind of notation and why machine learning is needed in the why linear algebra is needed in the machine learning. So we have come across some kind of notation for scalar, vector, and those things. Yes. So I'm also we can state that there is an independent operations behind it. So what all are the operations that we can do is that behind operations, which is normal in the 10th and 12th mathematics we have studied, right? So similar to that. So addition of two vectors is possible, subtraction is possible, multiplication of matrices is possible. So these kind of some operations are possible. I know that you guys, every engineering background students will have these kind of application. So these kind of understanding. So I'm skipping those things. So how to find an inverse, how to do transpose of a matrix, transpose. So these kind of some kind of operations. So these are all just not needed that much. So these are some kind of things that are present to do in a tensors. So let's come into an important discussion, that is norms. So in norms, in ML, we know that everything is represented in the term of vectors and matrices and tensors, anything. So vectors and matrices. So we can't comment how the individual vector matrices which will look or how the significance is. So we use the term called norms. So norm is nothing but an ideology or a concept which is used to find out or to estimate how big the vector is. So it is used to estimate how big a vector or a tensor, which is a vector or tensor is. So it is used to find out that. That is what the exact definition of norm. So let me give some mathematical idea over it. So it is some kind of representation, how we can represent a vector. Okay. So vector, it is an 2D or some kind of things. Let's take a point 3, 4. So if we plot x-axis 3, y-axis 4, this is the point. If we connect both the things, then this is one vector. So how we can write this vector, which is 3i plus 4j. So which is one vector. So this vector can be represented as the coordinate system. We can represent as 3, 4. In a complex method, we can represent as 3i plus 4j. So many definition. Even we can represent a vector which is alpha e power j gamma. Like that way also j beta. The angle and the rotation. This way also we can represent. So many ways are there to represent a vector. The norm is a thing that we can find out from this vector. So the norm of this vector can be found out from the individual root square. So 16 plus 9, this will be 25, right? So if we take it 5, so norm of this vector will be 5. So it is nothing but the distance. So it is saying the distance of this thing. So this is how the norm. This is nothing but a similar to the mathematical thing. So this will be used to find out how big the vector or a tensor is. So machine learning uses a tensor as a basic unit of representation. In ML, in machine learning uses tensors as a basic unit. Machine learning uses tensors as a basic unit. So we need to know that machine learning will consider as a default unit as a tensor, which is higher order. Even lower order will also be represented in tensor, but it is designed in such a way that it is can handle any kind of dimension, basic unit of representation. So two reasons to use norms. Two reasons. So one is to find out the distance, right? Two reasons of using norms. So one is to find how big the tensor is. How big the tensor is. That we have started now. And second reason is how close one tensor is to another. How close one tensor is to another. So this is used to find out some correlation between the things. So if we represent that the thing, there will be two vectors. So here one vector and here one vector. Okay. So if we know that there will be distance of connecting between those things. This is the distance. So this vector we can state like this one. So this is v1 vector. So our representation stating this is v1 vector and this is v2 vector. So we need to calculate the del v, which is nothing but v1 minus v2. So this will give you the difference between both the two vectors that is lying in a page or lying in a plane. Okay, so this is why we need another norm is used for another one. So let's get into the exact definition of norms. So norms are a way of representing length. Norms are a way of measuring or representing a way of measuring the length of vectors. Okay, so we already found out, right? So how to find the mathematical representation of those things. So this is how the quick introduction of norms. So this will be fine for the norms introduction. So which is nothing but some internal criteria things that the ML or model that it will uses. So we know that, right? The machine learning is the fundamental thing that will be handling the norms to find out the correlation between two vectors. For example, if we are giving two images and we have to make a regression or a logistic classification, like the kind of classification is coming, classification problem, then we will be using these kind of norms concept to find how is the distance between those things. So based upon this distance, it will calculate the distance between all the points that is present in the classification or the samples that we are giving. So then from the norm or a distance between all the things, then it will coming into picture like how we can calculate the distance between those things, and it will form another one classification from itself. The model itself will create to it and classifies everything. So these are some kind of representation that can handle. Okay, so then we are going to start another one important thing in linear algebra, which is linear combination. So far we saw is not that much important. So from here we will be getting into the core. So linear combination. So what is meant by the linear combination? Linear combination is the set of vectors is given by multiplying each vector by a corresponding, for now just to go through it, I will be explaining it clearly, by its corresponding scalar coefficient. And adding the result. So which is nothing but every plane will be having a unique vector. So or even a given scalar user vector. So the summation, that is a user vector or a given input vector, which is v of I, which will be individually multiplied by a alpha I. Each vector will be having a scalar weight to be multiplied, which is similar to that of our models. So each vector will be multiplied by a weight, and then each is multiplied, each is added. So each is added to get an output. So how it will look like the alpha 1 v1 plus alpha 2 v2 plus alpha 3, like that way it go up to alpha n v of n. So this is how the vector may be of any order, maybe tensor of 5th order, tensor of 7th order, anything, that is not needed. So this is how the output will be. So each layer at the output, each node at the output will be represented in this value. So based upon this thing, if the value is greater than 1, then that will be normalized, because everything is probability here, right? So that will be normalized. So based upon these kind of observation at the output level, the thing will be calculated. Then output vector will be stimulated based upon here one output to be produced, here one, here one, here one. So for example, it's 0.3, 0.4, 0.1, like that is coming. Mean 0.4 is the highest, means then it will take decision based on that. So this is how models will take decision from this. So for that we need linear combination of each thing. So for an example, if the node is 3 node and an internal 3 node and inner 2 node, then again T node. If it is coming, means every node will be connected. So like that, I'm getting simple example. Here we will be having some output that will be alpha 1 v1, beta 1 v2, like that way everything will be there, right? So based upon this thing, this kind of vector will be produced at the output. From that the decision will be taken. So here will be weights will be added, be alpha 1, beta 3, like that way alpha 2, any kind of weights will be added. So this is how models will be looking. So these all are inner nodes, And these are our layers. Here you see 1, 2, 3, three hidden inner layers and one input or output nodes. So this is how the models will work. So for this only we need a vector and those kind of representation. So now let's get into another one topic called span. So these are some mathematical terms which may be vague, but it will be helpful for you guys if you guys understand it. The span of the set is the vector. The span of the set of vector is, we can simply represent as a set of vectors, set of all vectors obtained by linear combination. So lastly we done, right? So some kind of scalar are multiplied to each vector and we are getting some vector. So similar to that, using that set we are getting all the possible vectors by linear combination. So that is what span, linear combination, by linear combination of the original vector. Okay. So span is nothing but there will be some constant fundamental v that is given by the user with some constant or scalar that is multiplied and added together to get all possible vectors from it. So linear combination we have seen. Now linearly dependent we have seen. Linear combination and span we have seen, right? So combining both things, now we are getting into linearly independent vector. So this is one of the very important term. So linearly dependent and linearly independent. A set of vectors is linearly dependent if none of the vectors can be written as a linear combination of other. So which is the set of vectors? Set of vectors is linearly combination. I can skip this one. The set of vector if none of these vectors, like we will be getting some spans, right? So we will be getting all possible vectors. So from that, if the none of the vectors can be written as, none of the vectors can be written as a linear combination. Linear combination of other. I will be giving an example, don't worry. Linear combination of other vectors. Okay. For an example, we are having, let's take a dimensional vector 1, 0 and 0, 1. Here, whatever the span, this is v1, this is v2. Whatever the span you do, span means nothing but we are multiplying coefficient like alpha, maybe multiply 2, multiply 3, multiply 4, anything, and add any kind of vectors and do anything. But this vector cannot be represented by this vector. You see here it is 0. Whatever the scale we multiply, we can't get a value here. Okay, so any kind of linear combination multiplication that we done, we can't span this vector into this vector. So if that is the case, then these two vectors are linearly independent. So that is what the example that we can give. By the linear combination, so one vector cannot be represented in the term of another vector by its linear combination. So linear combination, as we discussed, right? So which is nothing but the multiplying a constant or coefficient to that and adding all the vector together. So that is what the linear combination. The span is the thing that what are the all possible things that we be able to get. So combining both things, for one vector can be represented by another vector. For example, v1 is any combination or any possibility that can be represented as a v2, then these two vectors are linearly dependent. If these two vectors cannot be represented by any kind of linear combination, then we can clearly state that this is a linearly independent vector. So why this dependency and independency is needed in ML? So now only we stated a regression problem, right? So how the classification model will work? So in classification, we know that one kind of model can be, one kind of points cannot be represented in another one term. Then we can clearly separate those 2 points. This point is separate and this point is separate. So that kind of differentiation or separation we can make into it. So similar to that, we can be able to classify each vector or each point in a given labeled data. Then we can separate those things as linearly dependent and independent. So let me give one idea, give an example. So here we see, right? So it will calculate the each vector it will have. So for example, v1, v2, here v3 and v4. Okay, it will do linear combination v1 to v1. So v1 can be linearly combined as v1. So then that is dependent vector. So it is clubbed together. This is one thing. But V1 cannot be spanned to V3 or V4 as it is in different region. So then it will be combined, it will be considered as a linearly independent. So then there will be separation will be based on this one. So similar to that only, the ML model will take decision, or it will use its algorithm to separate the points or vector or labeled input based upon this. So these kind of understanding or representation where it is come is from this kind of linearly independent or span and linear combination of mathematical idea. So that is why mathematical background is needed to become a perfect ML engineer. I hope this is very informative for you guys. So if you guys have any doubt, please post in the comment section. So I will be good to answer all the questions. So like, share and subscribe to the channel. Stay tuned for more things. I am going to do many projects and those kind of things here. So best of luck for becoming an AI native engineer. Also follow the LL project course where we are doing many kind of real world problems. So please watch those things also. Thank you. Stay tuned guys.